This is Take 5 with Bentley, Nevada. In the studio again today, James McDuffie, Senior Staff Software Architect for Bentley. And James is very focused on cybersecurity across the business, and in particular right now, very focused on cybersecurity for the Orbit 60 platform, as that new platform is being launched to the marketplace as Bentley's flagship offering for machine protection. James, we've talked about Orbit Studio and the config environment. We've talked about the interface with System 1. There's another piece of interfacing to the outside world, and that is the communications gateway and its ability to talk to a DCS, a PLC, SCADA systems, and so forth. And there's really two elements to cybersecurity, as I understand. One is the hardware itself and the architecture itself, and the other one is the protocol that you choose. So let's first talk a little bit about the hardware and the security there.
Sure, absolutely. So we kind of discussed it a little bit in one of the previous episodes, is understanding what the 7 properties of a highly secure device are, right? And when it comes at it's establishing something called a hardware root of trust. And so when any piece of firmware or hardware boots up, it has to load its operating system, it has to load its firmware code. And as a part of that process, we burn specific encryption keys onto the hardware so that hardware can only execute the code that we say is okay to execute. And so this is how you build that firmware root of trust, because from boot up, from power on, we know that every aspect of the system is considered good. And so through this process, all of our smart cards make sure that all of the code that they're executing on them hasn't been tampered with or maliciously influenced. And so it is a very secure piece of hardware as a part of the whole system.
So almost this recognition of, hey, wait a minute, this code is not from us.
That's right.
Yeah.
And that also happens during the upgrade process. So anytime we upgrade to a new piece of firmware, that new piece of code has to be validated before the old hardware is willing to even switch over to it.
Okay. So this isn't an all or nothing, there's only one layer. I mean, there's multi-tiers of security going on
absolutely.
here. Yeah.
In defense in depth and defense in breadth. Absolutely.
So at the hardware, the architecture level, it sounds like those bases are covered, but there's also this aspect of, you look at the protocols that are used broadly in the industry right now. Modbus has been around forever, since the 1970s, and it's gone from like a serial version, Modbus RTU, to Ethernet, Modbus TCP, but it's still fundamentally Modbus.
Yeah.
You've got things like Ethernet Global Data, the EGD protocol, and there's other ones out there. But it sounds like in our discussions, one of the fundamental problems with all of these protocols that tend to be pretty broadly embraced right now is they're not necessarily that secure.
That's right. So unfortunately, these protocols just have no security aspect to them at all. I mean, they were built in a time for a need that was necessary for the industry, obviously. So they're valuable protocols. The problem is they just don't follow any of the modern standards. So there's no handshakes, there's no encryption, there's no verification. So there are protocols on the horizon that kind of address all of these cybersecurity concerns. So there is a Modbus Secure, there is an EGD Secure. These are kind of things that the industry is starting to look at and start creating the definition for what these protocols need to be to meet the industry need around cybersecurity. Unfortunately, 99% of the industry is still just using all of these old protocols. So the challenge here for us is, well, we still need to provide the functionality of what our customers are using in the field, but we also need to prepare by building hardware that can hopefully in the near future migrate to those better protocols and better technologies.
So again, what I'm hearing is the hardware is ready for these protocols once they're widely embraced by industry, once customers start asking for them. Because in some cases today, you could put the protocol in, but there's nothing for it to talk to on the other side yet.
That's right.
But it sounds like we're not talking about new backplanes, new chassis, new modules, as much as being able to put these new protocols in the hardware that you've already developed, the secure hardware you've already developed.
Yeah, that's right. So, I mean, it's not going to be an architectural change or a redesign to support these new technologies. It's the platform itself for Orbit 60 is really pretty flexible, and we've designed it to be extensible. So being able to change something from Modbus to Modbus Secure is really extremely minor. It's just a matter of when the industry has moved forward enough for us to actually start supporting it.
Well, we have managed to chew up 5 minutes just like that. It's always the way it is on these visits. But this has been good stuff, James. We've got a few more things we want to talk about, so we're going to invite you back. You've been listening to Take 5 with Bentley, Nevada, a Baker Hughes business.